know that feeling when an incredibly advanced AI just completely fumbles a basic logic question? Yeah, you're absolutely not alone there. Today, we're diving into the source material to demystify chain of thought prompting. By the time we wrap up this explainer, we're going to see exactly how to transform these models from fast-talking guessers into precise step-by-step logical thinkers. Let's get right into it. So, to kick things off, try to solve this deceptively simple age gap puzzle in your head. Ready? When I was 3 years old, my partner was 3 times my age. Now I am 20. How old is my partner? Sounds straightforward, right? But here's the kicker. If you ask a standard large language model this exact question straight up, it usually fails. It might just blurt out 60 or some other wildly flawed guess. So why exactly does the literal supercomputer fail third-grade math? Well, that brings us to Section 1, the predictor flaw, and exactly why AI struggles with math. The core issue here is all about how these models fundamentally work. With standard prompting, the AI basically reads your question and leaps straight to a guess. Remember, large language models are essentially highly advanced autocomplete engines. They're predicting text token by token. They aren't actually sitting there performing hidden internal calculations. When they jump straight to the final answer, they literally have no foundation to stand on. But with chain of thought prompting, you force the model to write out every single step. And here's why that's a game changer. Each generated piece of text becomes part of the model's own context. So earlier steps inform the later ones, basically building a sturdy ladder right to the correct answer, instead of just taking a blind leap. Moving to Section 2, the solution, chain of thought prompting. The actual definition from the literature is beautifully simple. Chain of thought prompting is just a technique that asks a model to generate intermediate reasoning steps before giving a final answer. That's it. Instead of demanding the final destination right away, you're demanding the journey. And honestly, the best part, you usually trigger this by just adding a few simple words to your prompt, like let's think step by step or explain your reasoning. Looking directly at the official prompt engineering source material, it's clear this isn't just some neat little trick. Chain of thought substantially improves performance on tasks that require multi-step reasoning. By asking the model to essentially show its work, you are fundamentally altering its processing mechanics. It stops trying to be a calculator and it starts acting like a sequential thinker. All right, Section 3, the proof, breaking down the math. Let's go back to our puzzle and walk through it exactly like an AI using chain of thought would. Step 1, the AI writes out, at age 3, the partner was 3 times 3, which equals 9. Okay, now by actually writing that out, the AI logically deduces the crucial next piece of context. So the age gap is 6 years. Then, step 2, it writes, now I am 20, so partner equals 20 plus 6, which is 26. See that? This step-by-step reasoning exposes that fixed 6-year age gap, which is the absolute key to solving the whole thing. And the AI only spots it because it was forced to write out step 1 first. And checking out the raw output straight from the source material, you can see it in action. When we just append that magic phrase, let's think step by step, the model successfully completely bypasses the trap. It calculates that fixed age gap rather than just blindly multiplying by 3. Boom, the answer is 26, and the logic is totally flawless. But hey, accuracy isn't the only win here. There's actually a massive secondary benefit: interpretability. Think about it. When a standard AI gives you a wrong answer, it's a total black box, right? You have absolutely no idea why it confidently said 60. But with chain of thought, because all of the reasoning is entirely visible, we can check exactly where the logic went off the rails if the final answer happens to be wrong. You can pinpoint the exact step where the AI hallucinated or made a bad assumption. It makes debugging literally so much easier. Moving on to Section 4. Supercharging chain of thought by adding few-shot examples. I actually really love this quote from the source docs. When you combine chain of thought with a worked example, meaning you provide a sample question, write out the reasoning yourself, and give the final answer right in your prompt, doing this teaches the model not only the answer format, but the reasoning style to imitate. You are essentially handing the AI a custom template for its internal monologue. If you want a specific outcome, this is for sure the most robust way to ensure the model tackles complex problems exactly the way you want it to. Okay, Section 5, the rulebook, best practices and trade-offs. Let's run through these quickly. First and foremost, you must always place the reasoning before the final answer. If the answer comes first, the context hasn't been built, and the magic just doesn't happen. Each step really has to inform the next. Second, you want to deploy this technique specifically for math, logic, multi-step planning, and coding. Basically, areas where the sequence actually matters. But, of course, here is the trade-off. More reasoning means generating more tokens. And as we know, in the AI world, more tokens mean slower responses and higher compute costs. You are literally paying extra for that thought process. And for the final rule, I want you to burn this number into your memory. 0. When you're using chain of thought for problems that have a single definitive correct answer, like a strict math equation or a specific block of code, you should set your AI's temperature parameter to exactly 0. This reduces the model's randomness and creativity down to the absolute minimum, which ensures it stays strictly on that logical path you've laid out. No creative detours allowed. All right, let's pull all of this together with our key takeaways from today's explainer. Remember the foundational truth here. Large language models predict text, they do not calculate. That's what causes those multi-step reasoning errors in the first place. Chain of thought addresses this head-on by forcing step-by-step reasoning, which builds reliable context on the fly. It's a remarkably simple technique that drastically improves both accuracy and interpretability. And if you absolutely need bulletproof logic, it is at its strongest when combined with few-shot worked examples. Which brings us to a final thought. Chain of thought prompting really is a game changer, but as we discussed, it isn't free. It takes more time and it costs more tokens. So the next time you sit down to write a complex prompt, you have to ask yourself, is the extra time and token cost actually worth it for absolute logical accuracy on this specific task? I'll leave you to ponder that one. Thank you so much for joining me for this explainer, and happy prompting.